Hello, Airbus Cockpit Coach here. This video is a short tutorial on how to set up an A320 series of aircraft from its cold and dark state all the way up to the before start checklist. We'll explore the various switches, systems and procedures necessary to successfully power up the Airbus, including the essential checks we perform. We'll start familiarising ourselves with the cockpit layout and identifying the critical systems and instruments that require our attention during the startup process. We're using the Fenix A319 here as an example today, but this video is applicable to any of the A320 series of aircraft and also the Neo as well, so it could be the fly-by-wire A320X for example. So you can use it across the series. So as flight crew, we would have been in the briefing room before approaching the aircraft, and we would have gone through our flight preparation. We would have looked at the flight plan, the weather, the NOTAMs, anything that we may already need to be aware of with the aircraft that's been pulled out and brought to our attention. We'll be discussing with the cabin crew any specials we may have on a particular day that we need to take into consideration for our flight. So once we've done that, we're all happy, and obviously discuss fuel as well as part of that. Proceed over to the aircraft. We'll jump in a bus, usually a little minibus, and it whizzes us around to our aircraft, and we'll get out and we'll have a view very similar to this one as we approach the aircraft. Now there's a few things as pilots we always sort of observe and take note of as we approach the aircraft. Although we do a walk around, it's good to know that we have the ground power connected, for example. That's useful to note. That's a tick in the box, excellent. But we may have lead air being supplied from the ground in some cases. There may be some engineers still working on the aircraft we need to be aware of, or is there loading already underway, and those kind of things. So as soon as we arrive at the aircraft, we do take a sort of a first glance at what's going on and giving us an overall impression of the status of the aircraft, and that's a really handy thing to do as you're getting on board. So we jumped inside in its cold and dark state. We've got nothing on at all. There will be a few checks we would run through initially, which I do have other videos on. So one of the first things we'll be doing is pulling out the technical log, looking at the maintenance status of the aircraft, any previous defects, what's been completed on the aircraft, is making sure there's nothing outstanding from that point of view. So we need to accept it from a maintenance position. We'd also be running through the circuit breakers. I do have a separate video on the circuit breakers, so do take a look at that. It runs through in detail what we look for, making sure these are all in position and there's nothing out of place or abnormal. With that, we want to check that safety equipment's there, gear pins and so forth are all present in the cockpit. Those are kind of things which the circuit breakers may move, but in the sim obviously we don't have a technical log as such, so not so pertinent to the flight sim world, but it's things we do need to check in the real world to get our aircraft acceptance done. I do have a specific video also on aircraft acceptance checks, so do check that out as well. It runs for that kind of documentation in a bit more detail. One thing from a home flight sim perspective I always do at this stage is make sure my controls are working. So my thrust levers are moving, side sticks moving, and I've got movement on my rudders and the tiller there as well. There's nothing worse than running through all your checks, getting the aircraft set up and realising you've got a hardware fault. So do that first. The next thing we do is make sure that the aircraft is in a safe state to receive electrical power and be powered up. One of the first things we do is come down to the pedestal and check that our radar and predictive wind shear system's off, which it is. These switches here, make sure they're hooked over into the opposition on each side. Then we make sure our engine mode selector is in norm. So that's the middle position. And we also want to make sure our engine 1 and 2 masters are in the off, which is the back position there. Then we come up and make sure our landing gears levers down for obvious reasons. We also want to check that the wipers are off on each side. There may have been some grit blown onto the windscreen since its last flight, and if they were inadvertently left in an on position, you can easily scratch the windows on the Airbus. So we want to make sure those are both in the opposition. I'm not going to power up. And then we come up to look at the battery voltages. So we want our batteries to be above 25 0.5 volts on each side, so battery 1 and battery 2. We'll check these voltages. As you can see, we've got 25.7 just above and 27.6. The Fenix does model some variations on the battery voltages, so do keep an eye on that one. The process for dealing with an undercharged battery is to leave it running on the external power, so the ground power unit, and leaving the battery in the off position. So we'll connect those, leave those off, and let them charge for 20 minutes or so, and then we'll recheck those voltages and make sure they're charging. If they weren't charging up, we'd have to call maintenance, because obviously an issue there. So we check the voltages, then we'll turn on the external power and battery 1 and 2 into the auto position. So auto is essentially no lights displayed. That's a common theme across the Airbus panel. So you'll hear the aircraft has come to life. We've got self-test in progress. We're just waiting for the warning computers to come alive. You hear a few noises when that test is performed on that system. And once that's done, we can do our APU fire test as the next stage. So we'll hear a chime shortly. There we go. So that's the flight warning system is now powered up. And the next thing we'll do on our check is come up here and make sure our APU fire system is working correctly. So we push the test button, and we want to make sure that we get a squib light lighting there. We're going to get a warning light here, and we'll get an ECAM here for the APU. So we'll push that in. To do that, hold it with the left mouse button, and then hold down the right mouse button to move around. So we've got the squib, and we've got the main light there. We have the master warning and the APU fire on the upper ECAM. So that's a good test. We'll then come over and put our ADIRS system into nav mode. So this is the inertial reference system of the aircraft, of which we have 3 different systems. And we turn the left side on first, then the right side, and then the middle side. And the reason we do that in that order is so we can distinguish. Left is for the captain side, ADIR 2 is for the first officer side, and ADIR 3 is for the standby. It's basically muscle memory, knowing which system to turn off in the event of an issue, so you don't turn off the incorrect one. So if we had an issue with the first officer side, it wouldn't be 1, 2, 3. So you wouldn't move the middle one, it will be the right side instead of the middle one. So it's just to get into the habit of learning where system 1, 2 and 3 are, because they're not in sequential order there. Once we select those to nav, we also consider at this stage starting the auxiliary power unit, the APU. There are some restrictions at some airfields, so it can be delayed to until before engine start, but you may need it on if external power is not available, so that's an option there. For the sake of this tutorial, I'm going to turn it on. So turn it on, we press the master to on, and we have to wait 3 seconds before pressing the start switch beneath. You'll see on the lower ECAM it's automatically brought up the APU page, and you'll see our figures start to rise shortly for the exhaust gas temperature. What you'll see is exhaust gas temperature rise pretty high, and it will drop back, and then the APU will come online. That's quite normal. Here we go. The exhaust gas temperature rising. Starts to drop back. Settles down, and then this you've got avail now, so we've got APU power also available to us as well. Now the APU can start off the batteries of the aircraft as long as they're in good condition, so that is a source of power should ground power not be available. So we usually wait a little bit of time before turning on the bleed air to the cabin. We start the timer on start of the APU. Usually a minute, up to 3 minutes may be advisable. and that's just to burn off any sort of residual oils in the system. So there's no fumes entering the cabin, so that's always recommended. Let's say we've surpassed 1 minute, and we'd put the lead on, and that starts to then air condition the cabin, and you can see both packs are now powered. The fault lights have gone out, and obviously we can then adjust the zone temperature as well. So you may want to consider for passenger comfort, if it's a hot day, reducing that, or increasing if it's a cold day. So we'll turn those down a little bit today to get a bit of cooler air into the cockpit. We then check that all the annunciator lights are working. So we've got this button here, switch here, sorry. So yeah, everything lights up, even down the pedestal as well. So, it's like a Christmas tree. And you can also, with this, control the brightness of those switches as well. So normally have it in the bright position, and then we want to adjust our displays. So we have the controls here for the primary flight display, which controls this one, and the navigation display has 2 rings to control it. So the first ring controls the overall display brightness, and the back ring controls the brightness of the weather radar. So we want to make sure that's bright enough so we see it, we're not hiding that information. So that's also one to check. And then down here we have the brightness controls for the upper ECAM and the lower ECAM. So adjust those so you can see everything there. The MCDU does have brightness controls here on the right, so use those as required. We have main panel floodlights and integral main panel and pedestal lights there. I want to make sure those are illuminated, so these got lights that shine down here. We also have lights controlled here by these. That's the brightness of the displays with this dial. And we have the backlighting of the controls, the integral lighting, which I don't actually need on today. And we also have another one here which there's a lights, I can't see it too well because it's daytime here, but it lights up this screen area and sort of shines down. Quite handy if you're doing a bit of paperwork here and it's you know, pretty dark during cruise or whatever. It just gives enough light to be able to do that. Alternatively, you can come up here and turn the dome light on, which is here. There's a dim and a bright setting for those, and you've got these 2 larger lights up here which light up the whole of the cockpit pretty well. And on the overhead panel as well, we also have the integral lighting control here. So throw that light up, and you can see all the green lines and the orange glow of the backlighting come through. That's all done, you know, by personal preference, but the important thing is that you can see all the information you need to see. We'll then come down and we would press recall, and see on the upper ECAM we have the normal comes up, the normal indication. If there was a fault with the aircraft that's been inadvertently cleared, it would show at that stage. It would bring that back up to the forefront, and we'll then be aware of that. You actually want to press and hold that for 3 seconds. Then we come on to the system display page. So this is operated down here. It's on the door, and we check the oxygen pressure. So 1800 psi there, which is more than sufficient for a flight. Then we come over to the hydraulic display page, and we check that the reservoirs for the hydraulic systems, which there are 3, green, blue and yellow, all have sufficient quantities. So they should all be in this little green range here at the top. So the line on the left should meet that green range. Then we come over to the engine display page. It's over here on the left, and here we're looking at the oil quantity. So on the A319 and 320, you want to check that the oil quantity is at or above at least 9.5 quarts, and as a rule of thumb, an average consumption is 0.5 quarts per hour flight. So you also want to be checking that you've got enough for your scheduled days flying, really, especially if you're not coming back to base. So they're usually topped up at night, the aircraft, and that's usually dealt with. So it's unusual to see low quantities there, but it's definitely one to keep an eye on. In the Neo, you want slightly higher oil quantities. You want at least 10.6 quarts of oil. But the Neo will burn slightly less, so it's about 0.45 on the oil burn per hour. Now the duties on the setup stage are obviously split in the real world between pilot flying and pilot not flying. Whilst one of us are doing checks, the other one will be then getting airport and weather data, starting to look at our preliminary flight plan, which I do have a separate video on, and also our takeoff performance. And obviously we need to perform the walk around, so our exterior walk around checks of the aircraft. And again, I do have a separate video on that, so do check that out. It runs through the detail of what we check there. Before we send somebody out for the walk around, we want to make sure that our nav and logo lights are on, our accumulator and brake pressure is sufficient. But actually, at the moment it's not, so we don't have anything in the green ranges. That's because the aircraft's been left overnight and that pressure drops. So the ACU press stands for accumulator pressure, so it's essentially stored pressure. It can only store a certain amount of pressure, and if it's used up through operating some of the aircraft doors or applying the brakes, that will drop. Opening of the starboard side cargo door will automatically trigger the electric pump to come in. To boost that, we can come up here and turn on the electric pump and on the yellow system, and you will see that pressure rise there. There we go. That's boosted up, and a little bit more stored pressure now. I want to check the position of the flaps, so the flaps are up, the speed brake lever is up, and the parking brake is now on. It's not unusual to find the park brake off, as the aircraft will be chocked. The park brake relies on the accumulator pressure, which drops overnight, which is the reason why we chock the aircraft. Again, I do have another video on the accumulator system, so check that one out for more detail into that. Once we check those things, then the walk around can be performed. Then we do our overhead scan. So the overhead panel is split into 3 parts, so we do actually have some clearly defined lines here in terms of where the panel has been put together. This is section 1 up to this line. Over here we have section 2 in the middle, and over on the right side beyond that line there is panel 3. So we break the panel down into the 3 parts. So we start with the left hand panel. We start at the bottom and work up. Basically we're looking to ensure that all the white lights are extinguished. I quite often do a check of the call bell and make sure that's operating. It is. We'll come on here and turn the oxygen crew supply on, which then supplies pressure to our oxygen masks. We leave that off overnight because you may lose a little bit of pressure as through small leaks in the mast and so forth. So that's the reason that's off, so we maintain the pressure in the aircraft. We then put our flight recorder into to ground mode, so it starts recording what we're doing a bit before the actual flight phase. And then we do our cockpit voice recorder test, so we hold that switch in here, get that tone, that's the test complete. And then we come up, we don't touch these, they stay guarded, and need to touch those. We put the evac control into captain, so you have the option of allowing evacuation to be commanded by the captain, so the cockpit essentially, and the cabin, but we usually have that, certainly my operator in the captain selection, but other operators may vary, so that's a bit operator specific. Where we dealt with the ADIRS system here, so that's set up, we can display our information here, so just in terms of heading and what's that looking at, but you'd usually have that on. Usually position, and you can see what each system is showing for each of those parameters, so the wind, present position, heading, and so forth. It's not something we really look at during flight unless we've got an issue when we need to confirm something. Then we come back down and we start on the middle section of the panel. Again, ensuring that all white lights are out, so it wouldn't be uncommon to see at this stage that the packs are off. If refueling is taking place, we want packs off so we're not drawing fumes into the cabin. There are a few lights here which at this stage make sense in terms of being there, in terms of the whites and the ambers. That's just to do with the condition we're in at the moment. They work up, so strobe would come into auto. That ensures that the strobes automatically come on if the wheels are off the ground. The beacon would check off for the moment. Wing lights we don't generally use, so only as required. They're used to check if ice is accumulated on the leading edge of the wing. Turn off lights to check off. Landing lights off for the time being and retracted, so we're in that bottom position, and the nose wheel light will be off as well. We've already put our nav and logos on as part of the earlier checks. Seat belts can come on if refueling is completed, so let's say now refueling is complete, so we'd have seat belts on. No smoking is auto, which is the middle position, and the emergency light switch is armed. This ensures that if we lose power to the aircraft, that the emergency lights come on and operate off the battery. For the cabin pressure selection, we want to make sure this control here is in the auto position. We check that our anti-ice, so window and probe heat, we'd check is dark. That's always they operate automatically, so they should normally be powered when we need them during flight, essentially. So when we're operating the aircraft, it's powered up. These will be heated. So just make sure that switch is dark. These aren't required at the moment because their engines aren't on and we're not in icing conditions, and the same with the wing. We don't want wing anti-ice on at this stage. We've got the APU bleed on, which is sensible. We do want to check our pack flow, so I do have another video on the pack flow valve itself and when we adjust that. So but essentially, as a rule of thumb, if you got below 130 passengers on board on a 319, a 320 or 320 Neo, you want to be selecting that to low. If you're on an A321, that's a little bit different. Below 160 passengers, you'd put that to low. If it's abnormally hot and humid, you'd use the high mode to blast more air through the cabin. If you've got a really uncomfortable aircraft, if you're sitting in a really hot part of the world for too long in the baking sun, that's where you'd be using that one. Otherwise, you want it in the norm position if you've got a full load of passengers but normal climatic conditions. We've already adjusted our temperatures here. We haven't got our engine generators on because the engines aren't started, so that's normal to see the fault there. We've got external power connected, that makes sense. All these should be dark because they're in auto. Once refueling is complete, we can turn the pumps on. And then we want to make sure our cross-feed valve is also in auto. Come further up. There's no white lights here. That's all operating automatically. And then we want to make sure that all the fire switches are guarded. So anything that's red has an irreversible action. So once you press one of these red guarded switches, and you're going to need engineering to rectify that situation. Anything that's black guarded, so the ram air here, for example, the emergency call button, that can be reset. And then we want to do the engine 1 and 2 fire tests. So very similar to the APU, we hold in press the test button, use the right mouse to look around, making sure we get the main light lit up and both squib agent 1 and agent 2 lit, and then we come over and check the master warning and the ECAM, and also a light on the pedestal behind the engine mode selector. So all our lights up there, master warning, ECAM, and you'll see the fire light behind the engine 1 selector. That's a good test, and then we'll test engine 2. Same thing, we've got the lights there, master warning, ECAM, and the pedestal. That's a good check. Then we come down and we check the right panel. There's not so much to do on this one. It's essentially a case of making sure everything's guarded, no white lights, everything is where it should be there. So yep, it's all dark, and that's a general Airbus theme. We shouldn't see any white around, and you shouldn't see anything amber. We've obviously got a couple of ambers because we haven't got the engines operating, so that's associated with that. That's normal. Whenever you're scanning around, you're looking for things like that. All white lights extinguished, and all amber lights. There's definitely nothing amber or white on that side of the panel, which is great. Then we do the sensor instrument panel scan, and we come down and check our standby instrument. I do have a separate video as well, just on this, so you can go through all the settings. Got a little bit more functionality than just what you see there. You can put in some bugs and things to mark certain speeds and altitudes. That video shows that. But we can adjust the brightness here on this side. It does automatically adjust its brightness in the real world. It's got this little square here, which is a light sensor, and it will do that. But we just want to make sure there's no flags in there. There's nothing telling us there's an issue with that, and it's working. We'll then come down and check our DCDUs are up and functioning, just in case we get any messages we need to respond to. These are the data link, display and control units, so it's all to do with sort of ACARs, our air traffic control messages, but also how we use those to acknowledge and respond to those messages. It is linked, so we can do the same actions within the MCDU as well. Again, we do another check to make sure the landing gear lever is down. We check the clock, make sure that's accurate. Anti-skid and nose wheel steering, we want to be in the on position. Brake fan as required. That's that switch here. It's not required at the moment, so we can always check that. So if you're just taken on an aircraft that's come in from somewhere else, it may still have hot brakes, so it's one to check. Then we come down to the pedestal. We check our switching panel selectors are all in the normal position, so straight up on all 4 of those. Want to check that our radio management panels are on, lit up, making sure it's not inadvertently left in the nav mode, for example, so that's closed and guarded. Something you sort of use in a backup scenario. Again, I've got a separate video on this panel, so do take a look at that one to go through the detail of that. We want VHF1 on. We normally, so we've got a Unicom tuned here. You may want to be tuning to obviously your local ATC station there online, and also we usually monitor guard, so it's 121.5 on VHF2. So we'd also pull that so we can listen to VHF2 as well. I just want to make sure these are illuminated and turned up sufficiently, so we're going to hear any communication on those receivers. So intercom volume, we select that, make sure that's on and turned up. This allows communication between the pilot flying, pilot monitoring, and also the ground crew with the headsets. We've got our lighting controls here. We've already looked at those earlier on, so they're already set up and adjusted as required. We've got the weather radar configuration, so in normal operations we have GCS into auto. Normal mode to have is this weather and turbulence is what's selected there, which is correct. System remains off for the moment, so we check those are off still. We check that the cockpit door is in the normal position. Parking brake handle is checked on. Gravity gear extension is stowed. Again, engine masters, engine mode selectors in normal. Masters 1 and 2 are off. Transponder should be in standby at this stage. We're an IFR flight, so we should have 2000 in initially until we get a code. The TCAS system should be in standby, and we want to be in above for our traffic selection, so we're looking up as we climb. Altitude reporting should be on. And usually we've got 2 systems. We usually adjust this, so if the pilot flying is in the left seat, we'll select system 1, and if the pilot flying is the right seated pilot, we'll select system 2. That's just one way of alternating between systems. Make sure they're operating correctly, giving them both some use. Once we've done that, we'll then start looking into our MCDU. I have a separate video on the MCDU setup. I won't go into that, so please do look into the MCDU side. It's a process we follow there in terms of how we set that up. Key things are we're checking the aircraft model, engine model and so forth at the start of that, the air act cycle we're on, performance factors. Then we come up to the glare shield, and we would be wanting to make sure that our QNH, so we're in Europe, so we're using it's a QNH. If obviously in the US, if you're using inches of mercury, you'd have it over on the left side, for example, that back switch. But in Europe, we use millibars, so we're over on the right side. You press the B key, that usually sets your local pressure, so we're 1013, or you can come down here, and if you load a flight up, you'll be able to then put in your weather information. So we've got our flight here, view our meter, and you see we've got the QNH of 90907, for example, if we were at this particular airfield, which we're not, but that's just some old data we've got in there just to show you that. And that's the data I would put in, so it's accurate. Then want to make sure our flight directors are on both sides. The landing system is as required. It's not required today. Sometimes we do use that as we're flying a back course. EFIS, so electronic flight information system. That's these top controls here, which control extra data we can see on the navigation display. Usually on departure and on landing. So when we're flying Citizen Stars, we'd have that on constraint. Shows any constraints that are built into our flight plan. We've got our range here for this screen. Initially for departure, we'll have that down to 10, the lowest. Pilot preference, that's the usual. You get the most information there, and as we speed up, you want to see further ahead, you would start to range out. If we had the FMS populated, you would see dashes here. See that our speed map window here is dashed. The 3 lines across, a bit like you do on the right side there. It's dashed. This would also be dashed because we were following a departure normally, unless we're giving a heading straight out. That can be either, but it's usually dashed because we'll be following a standard instrument departure. In the altitude window, we'd put our first cleared altitude from our charts, or whatever ATC has given us in our clearance. So we 6,000 feet, for example. Cross check that here. It's here as well. We'll be checking that the loudspeaker knob is set as well, so sufficient. And then we want to check that out on the primary flight display, that our blue and magenta speeds are matching the V1, V2. Flight mode annunciators are in. Blue here is matching our initial stop altitude, so that's confirmed. Just making sure that information makes sense. And then we'd also check that the position of the aircraft is consistent with the standard instrument departure, surrounding nav aids and terrain, etc. So we'll just do a quick check and make sure that does look sensible in terms of positioning. We'll then come down to the ECAM and we'll press the pressure page, and we want to be looking to ensure that the landing elevation is displaying the landing airfield data correctly. So our altitude at landing at the airfield, we'll cross check that, make sure that's in, and obviously you can cross check that also that's in auto. We'll then also check the IRS, so we come into the data page of the MCDU, and we come into position monitor at the top and make sure all those are aligned, all showing nav, and the position should be no more than 5 nautical miles. But checking all those systems there, so they're all within our accuracy tolerance. And then we're ready for the departure briefing. I do have departure and arrival briefing videos available to watch, so you can see what's covered in detail in those. So once we've completed the departure briefing, we've accepted the aircraft. Both pilot flying and pilot monitoring would confirm that they accept the aircraft, and they both say acceptance checks completed. We'll then cross-check our fuel, make sure the seatbelts are on using the upper ECAM screen. The pilot flying will check that the ADIRS are in nav, and also on this position page here, pilot flying and pilot monitoring will check the QNH and baro setting. is correct. So we're checking once here, twice here, and 3 times on the standby. We sort of cross-reference that so it shows our aerodrome altitude. So we're here in London Luton today, and that's showing a correct altitude. It's not, we're not at the reference point, but it's not 100 feet off, so we know that's accurate. And then it's time for the before start checklist. So at this point, we would be ready to start our engines. A quick scan around. No white lights. Lock the cockpit door. We finish speaking to crew. Maybe give a bit of a PA to the passengers. But yeah, at this point in the setup, we'll be looking to push back and start engines. So I will follow this on with another tutorial looking into the engine start and taxi checklists. So do look out for that one. If you have any questions on that, please drop them in the comments, and please don't forget to check out the channel memberships as well, where you get early access to the latest content. Thanks for watching.